Today, we're going to see how do we multiply rational expressions. The main idea here is that we are going to try and factor each expression and look if anything cancels out. Once that happens, we will multiply using the same rules as if it was a regular fraction. And in order for us to do that, you need to be really comfortable when it comes to factoring. What does all this mean? Well, let's put them into practice. Here, let's multiply the following. Now, notice that there's nothing to factor out because the expressions are already in factor form. So now we can move on to the next step, which is we're going to see if anything cancels out. Now, when it comes to multiplication, any expression divided by itself is equal to 1. 5 divided by 5, that's equals to 1. 3 divided by 3, that's equals to 1. Sure, we all know that. Now, why am I saying that? Is because when it comes to multiplication, any expression divided by itself is still equals to 1. So here we see that we're multiplying. See, I see that I have x minus 2 on top, x minus 2 on the bottom. So we can say that they cancel out, or they become a 1. Now, what do we have left? X plus 2 on the top, and x plus 7 on the bottom. Now you got to remember that when we're talking about rational expressions, you got to indicate when do we have an undefined. Now we cannot use -7 because if x is equals to -7, we will have 0 in the denominator, and that will make our answer undefined. So that's our final answer here. If you have the same expression divided by itself, whenever we're multiplying, then we say they cancel out. Now if we look at example 2, it's not exactly in factor form. So the first thing that we want to do is see if I can factor anything out. So let's look at the first expression, or the first fraction. Look, we have on the top, we have 4n minus 24. Let me try to factor it out. So I see that I can factor out a 4. So we have 4. What do I have left? I have n minus, what's that, 6? X minus 6. So the top, I factor out as 4, n minus 6. Now the denominator, I cannot factor anything out, so I'm going to rewrite it. 1, you cannot factor it out, so we rewrite it. N minus 9, you cannot factor anything out, so we rewrite it. Now what do you notice here? See if anything cancels out. I see that I have n minus 6 on top, n minus 6 on the bottom, so they cancel out. So now what do we have left? Again, we're going to try to multiply it as if it was a regular fraction. Top times top, bottom times bottom. So 4 times 1 becomes 4 on top. 1, because when they cancel out, they become a 1. So 1 times n minus 9 is n minus 9. Again, you gotta indicate what value. Well, in this case, it's not x, but n. What value of n I cannot use. I should not be using 9, because if I use n equals to 9, I will make the denominator equal to 0. So this is our final answer here. Try to see if you can factor anything out. Try to see if anything cancels out, and then you multiply as a fraction. So let's look at another example, which looks a little more complicated. Now, we're going to follow the same idea. Let's see if I can factor anything out. So let's rewrite the expression. So let's look at the top. 2n minus 6. I see that I can factor out a 2. So I get 2 parentheses w minus 3. So that's done. Let's look at the denominator. Can I factor anything out? I see that I can factor out a w. So w parentheses w plus 2. Now let's look at the top right expression. 3w, it's already a single term, cannot factor it out. So now what do we have here? 3 minus w, I can rewrite it just 3 minus w. Okay. See if anything cancels out. Well, notice that we have a w here and a w here, so they cancel out. Now, you might say, well, can w minus 3 cancel out with 3 minus w? No, they can't. They're not the same expression, but we can make 3 minus w the same as w minus 3. How? Well, 3 minus w, that is the same as negative w minus 3. They're the same. Why? Well, negative w minus 3, if you distribute that negative, that becomes negative w plus 3, which is the same as 3 minus w. So 3 minus w, we can rewrite as negative w minus 3. Why do we want to do that? Well, notice that, let me rewrite the expression, 3 minus w, I say that I can rewrite as negative w minus 3. So notice that if I rewrite 3 minus w as negative, shoot the same color here, negative w minus 3, now the w's minus 3's can cancel out. And that will make our answer in a more simplified way. So nothing else cancels out, so now we multiply like if it was a regular fraction, top times top. So 2 times 3, so that's 6. Denominator, w plus 2 times negative, so that becomes negative w plus 2. Now maybe you want to rewrite it as 6 negative w minus 2. Again, now this is going to be a little bit trickier. What value of w I cannot use? Well, I can certainly not use negative 2, because if I plug in negative 2 in here, so negative 2, I will have negative times a negative, so I will have positive 2 plus 2, which is equal to 0. You don't want a negative on the denominator, so that's why w cannot be equal to negative 2. So now that we have this done, this is our final answer here. Again, what we want to do is see if I can factor anything out. Once that is factored out, then we're going to see if anything cancels out. You cancel whatever it can be canceled, and then we multiply. Now, let's look at example 4, which looks a little more intimidating, more difficult, but it's fine. Now, again, what you want to do is try to see if you can factor anything out for all the expressions. Okay, so let's look at the top. X squared minus 3x minus 10. Can I factor that? Well, let's do our factoring here on the side. So how do we factor x squared minus 3x minus 10? Well, notice trinomial, 3 terms, second degree, coefficient of 1, so we can do the x method. What's the number that goes on top? 1 times negative 10, so that's negative 10. Number at the bottom, middle number, minus 3. So now we look, two numbers that if I multiply gives me negative 10, add them up, negative 3, so that's 5 and 2. 5 and 2, you want negative 3, so that's negative 5. So let's check, negative 5 times 2, that's negative 10. Negative 5 plus 2, that's negative 3. So I can rewrite x squared minus x minus 10 as x minus 5, parenthesis x plus 2. Okay, so we factor out the top, so that's fine. So now let's see, can I factor out the denominator, 5x? Nope, it's just a single expression, so there's nothing you can really do about it. Look at the top, 15x squared, cannot factor it out, so 15x squared. So now let's look at the denominator here, 3x minus 5. I see that the leading coefficient is 3, so I can factor out a 3. So what do I have left? X minus 5. Okay, so now that we have it into this form, let's see what cancels out. So I noticed that the x minus 5's are going to cancel out here. So what's left? I see that this x is going to cancel out with one of these x's, because you got to remember that x squared divided by x, this cancels out with this, so now you have just an x. So that's why this x can cancel out with one of the x squares here. What's left? Well, let's multiply, because maybe it's easier to see it once we multiply. So now, what do we have left? We have x plus 2 times 15x now, because this x cancels out with one of them. So divided by 3 times 5, that's 15. Okay. So remember that when we do that, it's just a lot of multiplications here. So now this 15 can cancel out with this 15. So what do we have left is x plus 2. And if you distribute that, it becomes x squared plus 2x, which is our final answer here. Now, it was a lot here, so let's recap. First thing I did, I factored it out. So we did that. Cannot factor out each expression here. Then I noticed that the x minus 5s can cancel out. I noticed that this x can cancel out with one of the x's here. So they cancel out now. I rewrote the expression to make it easier. X plus 2 times 15x, x plus 2 plus 15x, and the denominator 3 times 5, that's 15. Then I notice that the 15 can cancel out. Then I have this, then I distribute, and I had x squared plus 2x. Now let's look at example 5. Example 5, it looks difficult, it's fine. We're going to apply the same idea here. Can I factor anything out? Well, let's see. Again, let's do the factoring here on the side. So let's see, can I factor x squared minus 2x minus 8? So I have x squared minus 2x minus 8. 3 terms, second exponent, leading coefficient is 1. So I can do the x method. Number on top, 1 times negative 8, so that's negative 8. Number at the bottom, negative 2. Two numbers that if I multiply gives me negative 8, add them up, 2. So that's 4 and 2, that gives me 8. If I make this negative 4, so negative 4 times 2, negative 8, negative 4 plus 2, negative 2. So that says that the top I can rewrite as x minus 4 and x plus 2. Alright, so we rewrote the top, so here we have it. Now let's see, can I factor out anything on the denominator? I see that I can factor out a 4. So I have 4. What do I have left? X minus 4. X minus 4. Okay. Let's look at the top. 10x. Nope. So now, let's see. Can I factor out x squared minus 4? Well, notice that this is a difference of squares. So let's repeat that. X squared minus 4. You can rewrite that as x squared minus 2x. Now they have it in this form. It's a difference of squares, so you can rewrite it as x minus 2 and x plus 2. If you need help with the difference of squares, check out my previous videos. It's on it. It's a lesson for difference of squares. So now I can rewrite x squared minus 4. I can rewrite as x minus 2, x plus 2. So x squared minus 4. I can rewrite as x minus 2, x plus 2. So x minus 2. Well, x plus, well, it doesn't really matter if it's a plus or minus first, so let's be consistent. X minus 2, x plus 2. Alright, so I rewrote everything. See if anything cancels out now. Well, this x minus 4 is going to cancel out with this x minus 4. X plus 2 cancels out with x plus 2. Does anything else cancel out? Not really, so let's just multiply now. This whole thing it's 1, so 1 times 10x is just 10x on the top. This is 1, so 4 times x minus 2, so 4x minus 2. Okay, so that's our final answer. Now, what value of x I cannot use? Here, notice that the value of x that I cannot use is, what will this be? 2, because if I plug in 2, I will have 2 minus 2, which is 0. 4 times 0 is 0. So I will have 0 in the denominator. So x cannot be equal to positive 2. And this will be our final answer here. Now let's look at our final example here. Same idea. It looks complicated, but we're going to take it one at a time. It's a lot of factoring. So again, the first thing I want to do is try to rewrite everything. So let's see. Let's do the factoring here on the side. So look at the top expression, y squared plus 7x plus 10. Y squared plus 7y plus 10. How can I rewrite this expression? 3 terms, highest exponent is 2, leading coefficient is 1. So I can do the x method, number on top, 1 times 10, so that's 10, 7. So two numbers that if I multiply them gives me 10, add them up, gives me 7, so that's 5 and 2. So that says that the numerator I can rewrite as x plus 5 and x plus 2. Alright, so we just factor out the first expression. Now let's look at the denominator. I see that I can factor out a y, so let's factor a y. So y plus 5, excuse me here, I rewrote as x's, where in reality we're talking about y's here. You might get confused there, but it's my mistake here. So y's, because we're talking about y's. So now the denominator, factor it out, numerator, 2y, y squared minus 4, again, it's a difference of squares. You can rewrite that as y to the second minus 2 to the second. So that says that we can rewrite this as y minus 2, y plus 2, just like we did on the top example here. So now we have this. So denominator, I can rewrite as y minus 2, y plus 2. Okay. So now let's see if anything cancels out. Y plus 5 cancels out with y plus 5. Y plus 2 cancels out with y plus 2. Is there anything left? No, there's not. So let's rewrite this. Let's look at our final answer. This becomes a big 1. So 1 times 2y is 2y. Becomes a big 1. So y times y squared. So let's just write it like that. Now let's look at which values of y's we cannot use. I see that there's 2 values of y's that I cannot use. I can definitely not use 2, because if I plug in 2, so that's 2 minus 2, then this becomes a 0, and 0 times y is 0. So I definitely cannot use y to be equal to 2. Also, y cannot be 0, because if I plug in y for 0, then if I plug it in here, so 0 times anything is 0, I will have 0 in the denominator. So I need to exclude y to be equal to 0. And this is our final answer here. It was a lot, I know, it's a lot of factoring. Basically here we're mixing all the techniques that we have been seeing so far. But this is how you multiply rational expressions. You factor each expression, the top, the bottom, for each fraction. You see if anything cancels out, you write your final result, and you need to write down what values for the variable you need to exclude. Now for your entrance ticket, here you have it. Multiply the following. See if anything cancels out. Try to factor it out. Try to see if anything cancels out. and you should obtain your final answer. Don't forget to include the values of the variable that you need to exclude in your final answer.